Well, good morning, everybody, and welcome to another exciting Exploring by the Seat of Your Pants broadcast here with us. If you're new to us, like so many of you are today, we are all about bringing conservation, adventure, and science into classrooms around the world. Now, everything we do goes to our YouTube channel, so if you want to check this out 3 weeks down the road or share with family and friends after, you absolutely can right there. Now, I was just saying before we went live that we started this month with 2 epic storm chasers that were part of Canada's Storm Hunters team. They were really fantastic broadcasts. They're on that YouTube channel. And so it's fitting that we get to wrap up the month with one of my all-time favorite speakers. Now, I'll introduce him in just a minute, but I do want to highlight that we do have a Kahoot today. So if you're joining us live on StreamYard or on YouTube, head to the game pin below. We'll do a little 4-question quiz, test your understanding for some bragging rights between the talk and the Q&A. Now, I'm really excited you're joining us today of all days because we're back live with, as I said, one of my all-time favorite people we ever bring on, and that is Nick Underwood. He is with NOAA's Hurricane Hunters, which means for a living, he gets to go fly in planes into hurricanes and bounce around like a madman to go understand what's going on in the heart of these epic storms. The reason that we're able to save lives and guide people to get out when big storms are coming is because of the work of Nick and his team. So I'm really excited for you to meet him, dive in with his epic story, and see some cool footage in action of what exactly that's like. And so without further ado, Nick, welcome back to the program, and so nice to see you again, man.
Hey, good to see you. Thanks for having me.
I know you've got a lot to share, and I've been talking for way too long. So if you want to dive in with the presentation and show us a little bit of what this looks like on a day-by-day basis, we
Sounds good. Give me just a second here. All right, there we go. Good morning, everyone. As Jesse said, my name is Nick Underwood. I am the Programs and Integration Engineer at NOAA's Aircraft Operations Center, also known as the NOAA Hurricane Hunters. And so our office has a fleet of aircraft that we use for all different kinds of atmospheric and oceanographic science missions, including hurricane hunting, but also things like coastal mapping missions and marine mammal surveys and all these different kinds of science missions that the National Oceanic and Atmospheric Administration supports. And so today we're going to talk about one of the biggest missions that we support, one that impacts millions of people every year, and that is our hurricane hunting missions. And so I'm going to share a lot of images and videos that I've been able to take over the last several years that I've been in this job. I'm also going to share some images from other sources like NOAA's satellites. So for example, what you're seeing here is a satellite image of Hurricane Florence in 2018. And so this is when that storm had revved up to a large Category 4 hurricane working its way across the Atlantic Ocean. And this is Hurricane Dorian in 2019, when it was a Category 5 hurricane sitting over the Bahamas just off the coast of Florida. And so our whole goal of flying the aircraft that we're going to talk about today, is to go into these storms to collect the meteorological and oceanographic data that is so important in allowing us to predict where the storms are going to go and how strong they're going to be when they get there. And so image on the left, those are all of the flight tracks that our P3s flew into Hurricane Dorian back in 2019 as it formed down close to the Antilles and worked its way up towards the United States and ultimately made landfall up in South Carolina. And so our whole goal, like I said, of flying into these storms is to collect data that the forecasters can use to predict where these storms are going to go and how strong they're going to get. And so the image on the right, which you'll see more of today, this is one of the primary products that people look at that the National Hurricane Center in Miami puts out when there's a storm threatening life and property somewhere. And so we call this the cone of uncertainty. And so our aircraft go out, fly into the storm, collect all of this data, and the data that we're collecting feeds these forecasts. And that cone of uncertainty, as we collect more data, as we get a better idea of exactly what the storm is doing, that cone gets smaller and smaller and allows us to predict better in advance where the storm is going to go, so we can warn people, so people can prepare their homes, so they can evacuate, so they can be as prepared as possible to keep themselves and their families and their homes safe. And so we use 3 different kinds of aircraft. They're all named after Muppets, Kermit, Miss Piggy, and Gonzo. And so we're going to talk about Gonzo first. So Gonzo is a Gulfstream 4, it's a high altitude business jet that's been modified for us to go and track hurricanes. And so think of all of the airplanes that we're going to talk about sort of like flying research laboratories. And so Gonzo has multiple radar systems on board. And it's loaded with instrumentation. And so this aircraft flies up above, around, and in front of the hurricanes at 45,000 feet above the ocean. And so this is really getting an idea of those upper level steering currents. So the atmosphere around the storm that is feeding into it, and also steering it to where it's ultimately going to go. And so, like I said, Gonzo has multiple radar systems on board. One of the more important ones is what we call our tail Doppler radar. And so instead of looking outwards from us and scanning horizontally, the tail Doppler radar scans vertically. And so as we're flying around and through a storm, it's collecting little slices of radar data that the scientists can then piece back together and get an idea of the structure of the storm, of how it's forming. And so this is an example of what that data screen looks like. This was from Hurricane Eta in 2020. And so that big blob of nastiness off the right side, that is the hurricane core. And so as we're flying around the storm, we're collecting all this data, and it's getting sent off in real time to the forecasters on the ground. Very importantly, we use Gonzo and our other aircraft to launch dropsondes. And so think of these like weather balloons, but instead of floating up through the atmosphere, we drop them from the bottom of the aircraft. They have a parachute that deploys, and as they float down, they're collecting temperature, pressure, humidity, wind speed, and wind direction data. All of that is very important in determining how strong a storm is getting and also where it's going to go. And so as an example, this is from nearly 20 years ago at this point. And so our technology has only gotten better and better. But even back in 2005, with Hurricane Katrina, the red line on this graph was the prediction without using data from the dropsondes. And that predicted the storm would go into western Louisiana. But when you added the dropsonde data and compared that to the actual track of the storm, which was the black line, you can see how much better it lined up with reality of what actually happened. And so the more instruments we launch, the better that forecast is going to be able to be. We don't typically fly right through hurricanes with Gonzo. Sometimes we do overfly the center of the storm if it's weak enough for us to be safe in the jet up there. And so this is always a good example of that. This was Hurricane Jerry in 2019 when we overflew the center. So that's looking down on the eye of the hurricane from up above it. And so the other two aircraft that we use, Kermit and Miss Piggy, these are the ones you're going to see most of the imagery from today. These are our WP-3D Orions. And so these are big 4-engine propeller aircraft that we use to fly directly through the storms, usually between 8,000 to 10,000 feet above the ocean surface. And so these are really fleshed out flying laboratories. This is a picture of Miss Piggy, and Miss Piggy has 3 radar systems on board, one in the nose, one in this big M&M looking thing on the bottom of the airplane, and then it's also got a tail Doppler radar just like Gonzo does. We're also able to launch dropsondes from this aircraft. We have a instrument out on the wingtip that measures rain droplet size, speed, and direction. And we can also launch larger instruments out of this airplane as well, things that measure ocean temperature, things that measure ocean wave speeds and heights. And so all different kinds of data we're able to collect as we're flying through the storms. And so if you think of Gonzo focusing more on the track of the storm, of where it's going to go to, think of Kermit and Miss Piggy as focusing more on the intensity and the actual structure of the storm and how strong it's getting. And so we do fly these airplanes right into the eye of the storm. This is an example from Hurricane Florence from our lower fuselage radar. So you can see all of those nasty storm clouds around us. We were right in the center of the eye here. And these aircraft are nearly 50 years old. And so next year, in 2025, will be 50 years since Kermit rolled off the assembly line and came to NOAA to start flying into hurricanes. And so over that time, these airplanes have flown through a lot of different storms and been to a lot of different places to support all the different types of missions that we fly. And so if you look in this photo, all of those red hurricane symbols, each of those is a hurricane. I took this photo this morning. This is on the side of Miss Piggy. So this is every single hurricane that Miss Piggy has been through in her nearly 50 years of service. And so I do get to fly aboard these aircraft. Most of the time I am the person sitting in the back of the aircraft launching dropsondes and other things out of the airplane. Lately I've taken on more of a role of being a expert on our uncrewed aerial systems. So we're also able to launch small drones out of the P3 that can then fly down to a lot lower altitude than we can safely get to and collect some data that there's really no other way to get. And so this is normally where I sit on the airplane. And that window you see there, I've taken a lot of very exciting, awe-inspiring and terrifying photos and videos out of that window. And so people always ask, what's it like to fly through a hurricane? And it's a lot of this. It's a lot of wind and rain, not much to see. Sometimes, especially when we get deep into the eye wall of a storm, it gets very intense. The wingtip starts to disappear a little bit. But I'll fast forward here as we get further into the storm. And actually, we're just going to do it now. So this is coming out of the eye wall into the hurricane. This was Hurricane Florence in 2018. And so you see we're leaving those nasty storm clouds in the eye wall behind. And with stronger hurricanes, especially major hurricanes, categories 3 and above, a lot of times what you'll get is something called the stadium effect. And that is where the lower level clouds in the eye of the storm start to clear out. And you can get blue sky above you. And so we call it the stadium effect because it's like you're standing on the field of a football stadium looking up at all of the stands around you. So just to cut ahead a little bit here, maybe if it'll let me. There we go. And so this is us just, when we're once we're in the eye of the storm, we're hunting the center. And so we're trying to find the actual center of pressure, and that is where all of that swirling energy around the storm is trying to flow to. At that point, the winds in the hurricane drop to zero. There's no wind at that point because everything has reached its horizontal point, and then all of that energy, since it can't go down because the ocean's beneath it, it starts to flow up and out through the hurricane. And so, like I said, I've seen a lot of interesting things out the window over the last couple of years. This was the eye of Hurricane Ian in 2022. And what's very interesting about this photo is that you can still see the storm clouds. You can see that curvature of the eye up at the top. But what's very interesting is I took this photo at night. And so all of the light that you see in this photo was from the amount of lightning that was in the eye wall of the storm as we were flying through it. And this was the same storm, just another example of just how much lightning it was. Ian was going through a process that we call rapid intensification, which I'm going to talk a lot more about in just a minute. This was the eye of Hurricane Irma in 2017, a large Category 5. This was Hurricane Dorian. This was after it was Category 5 and it weakened down to a Category 3 hurricane. This was Hurricane Florence in 2018. Very, very spectacular to look at. Florence did end up weakening before it made landfall in North Carolina, but even making landfall as a Category 1 hurricane, it still caused billions of dollars in damage and cost a lot of lives as well. This was from Hurricane Milton, actually, just a couple of weeks ago, one that came right over my house down in St. Petersburg, Florida. And so even though Milton was still a Category 4 hurricane at this time when we were flying through it, and you can see the radar image here, that circle behind the aircraft, that was the eye of the storm, but Milton was experiencing a lot of what we call upper level wind shear. And so there was a lot of wind coming from outside the storm that was trying to blow it over. And ultimately, and thankfully, Milton would weaken a lot before it made landfall. And so just to give you an idea of how this looked, so you can see the radar image there, and then out the window, and then looking back. So that is the eye of the hurricane, but you can see how there's multiple tiers of that circulation. There's the lower circulation, and then a middle circulation, and then an upper one. And I always try to explain it like it's kind of like a stack of plates. And so the more wind shear there is, the more that stack of plates starts to get tilted over. And the more wind shear there is, the less powerful that hurricane can be. This is a time lapse just of one pass going through Hurricane Florence in 2018. And so normally when we fly through these storms on a single mission flight, which is about 8 hours in length, we'll fly through usually 3 or 4 times. On this particular flight into Florence, we flew through 9 times just because we had the extra fuel and the scientists wanted to gather as much data as they could. And this is just entering the eye wall of Hurricane Florence. And I want to talk really quick about the people that are on this airplane. And so it's a large airplane, and usually we have about 12 to 15 people on board. And so that includes pilots, meteorologists, flight engineers, electronics technicians, scientists from the National Hurricane Center. There's all of these folks that fly on board that have to work together to be sure that we are safely gathering this information and effectively gathering it. And just to give an idea of the different flight tracks that these airplanes fly, on the left is a flight track from Gonzo. This is around Hurricane Matthew in 2016, which was actually my first hurricane. And so you see Gonzo flies around the storm, out in front of it where it's predicted to go, sampling that environment around it. And you compare that with one of the P3 flights that just crisscrosses and zigzags and makes its way through the storm and out the other side. And so I mentioned rapid intensification earlier, and we're going to talk about that just for a couple minutes here. And so rapid intensification is when a storm, a tropical storm or hurricane, gains a lot of intensity over a very short amount of time. And so there's been a lot of examples of this over the last couple of years. It requires the right meteorological conditions. It also requires warm ocean temperatures. The ocean is really what is fueling hurricanes. It's where all of that energy that's getting transferred in the winds is coming from. And so there have been a lot of good examples of this over the last few years. Hurricane Florence was a great example. And so this is 2018. This was Tropical Storm Florence, this image. So I took this on September 8th of 2018. This is Tropical Storm Florence. 24 hours later, this is Category 2 Hurricane Florence. You can see the situation has changed a lot. There's a lot more, there's a lot bigger waves down here. There's a lot more storm clouds forming around. And then 24 hours later, after this, you had Category 4 Hurricane Florence. And so that's a very short amount of time to go from a tropical storm that has just formed to a major hurricane. And where this gets really dangerous is when storms do this very close to land, because suddenly you have a very powerful hurricane, in some instances a very large hurricane, about to make landfall, and that's less time for people on the ground to prepare their homes, to evacuate, to take care of their neighbors, do everything you need to do before a storm hits. Another great example was Hurricane Laura in 2020. And so we started flying this storm when it was still Tropical Depression 13 out in the Atlantic Ocean. And ultimately, it would make landfall in Louisiana as a Category 4 hurricane. And so just to kind of step through here, this was Monday, August 24th, 2020. This was the cone of uncertainty put out by the National Hurricane Center. 24 hours later, the storm had just moved off the coast of Cuba, and one of our aircraft would find it as a hurricane that morning. This was the 2 a.m. update, but at the 8 a.m. update, it would be a hurricane. And you can still see that this track, the forecast track, all of these H's mean it's going to be a Category 2 hurricane or below. It's not forecast to make major status yet. And this is Tuesday, August 25th. 24 hours after this, Wednesday, you now have a hurricane in the Gulf of Mexico. And now what do we see here? There's an M that's forecast as a major hurricane at landfall. And this is Wednesday, and Laura would make landfall the next day. And so what's dangerous here is that this storm gets very powerful very quickly. Why does this happen? Well, real quick, this was Category 1 Hurricane Laura when we found it that morning on Tuesday. And the following day on Wednesday afternoon, this was Category 4 Hurricane Laura. And so you can see it's much larger. The winds were much more intense. There was a lot more storm surge being generated by this storm. And if you look at sea surface temperature anomalies, and so anomaly means a departure from normal. And so this was from August 25th, 2020. This is as Laura is working its way across the Gulf of Mexico. And you can see over here that there's a lot of anomalously warm water in the Gulf of Mexico. This was about 1 degree to 2 warmer than the average. And what that means is that when you spread that out over hundreds of square miles that the storm is moving over as it goes towards the coast, that's a lot of extra energy that the storm has available to it to soak up, to transfer into damaging winds. Another good example of this was Hurricane Ian in 2022. So this was a couple of days before landfall. Ian would make landfall in and around Fort Myers, Florida, which is just down here. I don't know if you can see my cursor or not, but a little ways south of Tampa Bay. And as you can see, same story. Water that is a degree to two warmer than normal than we've seen over the last few decades. And interesting thing about hurricanes is that we know they're soaking up all of this energy from the ocean, because if you look afterwards, you can see that Ian had left this cold wake. And so suddenly, especially near the coast, you have water that is colder than the average. And so we know it's soaking up this energy. We know it's transforming it into this damaging storm. And a very recent example of this, just last month, this is an image, the first advisory that the Hurricane Center put out for Hurricane Helene. And so at the time, it wasn't even labeled a storm yet. This was potential tropical cyclone 9. But just to show an example of how good we're getting at forecasting where these storms are going to go and how strong they're going to get, we're putting out advisories to warn people that a storm is coming before the storm is even there yet. And so our office would start flying the storm on September 24th. This was that afternoon. At this point, the storm had formed. And as we start to get that reconnaissance data from the aircraft into the forecast models, you can see we're getting better. Already the forecasters were predicting Helene to make landfall as a major hurricane in the Big Bend region of Florida. And ultimately, this was Thursday, shortly before landfall on September 26th. At this time, Helene was a large, very large Category 4 hurricane, so large, in fact, that the storm never actually, this is more of a personal story, but the storm never got closer than, I think, 90 or 100 miles from Tampa Bay. It did not make landfall in Tampa Bay. It made landfall hundreds of miles north. But we have people at our office who had their homes get 4 feet of water flooded into it from all of the storm surge that Helene was whipping off of it into Tampa Bay. And so very widespread, devastating storm. Of course, people also know about the amount of flooding and devastation that took place up throughout Appalachia and places like Tennessee and North Carolina. I'm from West Virginia, so my heart bleeds for those folks. But same story with Hurricane Helene. This was the sea surface temperature anomaly on September 23rd. This water is 2 to 3 degrees warmer than normal. And so as oceans continue to get a little hotter, you can reasonably expect that when there's more energy available, that hurricanes are going to have more to feed off of. No matter how strong a storm gets, whether it's a tropical depression or a Category 5 hurricane, our office is going to go fly those storms, especially if they're threatening lives and property, or even if they just have research value. And so our mission is all about keeping people safe, giving people that warning of a storm is coming their way. And it's an excellent job. It's an exciting job. And it's a very good job. You know, we do a lot of good for people at this office, and I've been doing this work for the last 8 years, and it's really phenomenal. And I love getting to tell people about it, to talk about it. And I think, and just last slide here. This is not much of a cold wake left by Helene, and that's because Helene, as a hurricane, moved very quickly across the Gulf of Mexico. And so even though it was soaking up that energy in the ocean, it moved so quickly that it still left the ocean pretty anomalously warm. And so that's what I have to share. A little bit about rapid intensification, which is a very specific meteorological phenomenon, but also a lot about our office and the hurricane hunters and the mission that we support and the airplanes that we fly and how that benefits people all across the United States, as well as down in Central America and the Caribbean, and even folks up in Canada. You guys get certainly impacted by some hurricanes that swing north as well. So thank you.
Thank you, and thank you for the work helping us Canadians. I'm in Newfoundland now on the far east coast, and any effort that we know if the hurricane's coming up towards us, that's very appreciated. We had Fiona come and nail us a couple of years back when I moved here, so thank you for all of that. Nick, if you want to come out of screen share and see us again, have a bit of a conversation.
Yeah.
Dive in with our Kahoot first. So as I said, between the talk and Q&A, we're going to do a little question quiz together. So see who is paying attention, and what you win is Nick and I's everlasting respect and bragging rights. So that's kind of cool. Before we dive in with questions. So Ms. Doobie's class, we're going to come to you guys first after one online. YouTubers, please do share all your questions in the chat. We'd love to hear from you. But for now, here's our game pin. And if you're new to Kahoot, the faster you answer, the more points you get. So let's get into it, and we will get underway. And Nick, if you want to give us little hints for any of these questions, you're welcome to chime in with assistance of any kind.
All right.
All right. 2, 1, and question 1. What agency? Now, see, this is the thing. I would say that most people coming into this program don't know your agency is not name recognition like, say, NASA. But it's getting there slowly but surely, which is kind of exciting. And then the Canadian equivalents, we've been partnering with a lot of them over the last few years. So I don't know. Doesn't seem like you're in fish and wildlife. I'll say that much for you.
I don't know. I do. It's probably small to see, but it is on the shirt there. If people don't know.
Squint. So NOAA. So can you explain again what NOAA is for people that might have missed it at the beginning?
So NOAA is the National Oceanic and Atmospheric Administration, and so this is a United States government organization that is all about protecting our oceans and atmosphere and understanding them. And so I work as part of the hurricane hunters, but NOAA also has fisheries, the people that manage fisheries. We also do a lot of work with marine mammals. And so there's a lot, and it's also the National Weather Service falls under NOAA. So there's a lot of different branches to it.
Very cool. Thank you for elaborating. Decisive Cheetah has our lead. So we go into question 2. What's the highest category for hurricanes? We talked about a few categories throughout this. Is it 1, 5, 10, or 50? I think a lot of people are going to get this right. This seems to be something that really cracked through in storms around the world of people knowing this. Perhaps not. Get those answers in. 9 seconds to go. You've been in. Have you been in the highest one ever?
I have. Yeah. The highest category. Yes. I mean, strongest storm ever. That's. I don't think so. But.
How many 5s have you been in your career?
Milton was my 3rd. And so Hurricane Milton, Hurricane Irma, and Hurricane Ian are my 3.
Out of curiosity, as a question for you as we lead into our next one, does it feel tangibly different when you're in the plane and it's a 5 versus a 4? Is it just depend on the individual storm? Is there anything to that or no?
It really varies storm to storm. I mean, I've been in Category 1 hurricanes that just rock you like no other. And I've been in Category 4 hurricanes that gently let you through. Certainly the Cat 5s can be pretty mean. I know Ian especially and Milton were both very mean Category 5 storms.
Thank you so much for using the phrase rock you like no other. That just makes my day, so I appreciate you immensely. All right, question 3, 2 more to go, and then we're going to take our first question. So we highlighted this at the beginning. Who's paying attention? The Hurricane Hunter planes are named after characters from what show or series? Is it Power Rangers, Muppets, Batman, or Squid Game? I love that they're named after these. This really delights me every time we get the chance to talk. Do you have a favorite plane to be in? Are you only in one plane ever?
No, I fly on all 3 airplanes. I think I've spent the most time on Miss Piggy at this point.
Okay.
I think Kermit is second after that, and then Gonzo.
I'm really surprised that they're approaching 50 years old. Like, I really would have thought that like every 20 years, just for like, I don't know, epic safety reasons, you need to upgrade a plane. But no, a reliable workhorse of the hurricane world.
It really shows how good the people who take care of the airplanes are.
Yes. All right. The data the Hurricane Hunters collects helps give us a what-day forecast. How long in advance do we have a rough idea of where things are going to go? Is it 1 day, 3 days, 5 days, or 10 days? Now, we've had questions before in your broadcast about, like, why not like a 50-day forecast? And most people got this right, but why not longer than 5 days? Is there like a limit that we're going to get to eventually, or what do you think?
No, it's as we continue to collect more data, as our forecasting computer models have more to learn from. I think we'll continue to expand that out. And 5 days is pretty good. The National Hurricane Center does actually put out a 7-day forecast now, just so you know. So your question might be a little bit outdated.
I'll update you for next time. That's wild.
But that's a new product out of, I think, last year, actually.
Yeah.
But yeah, it's 3 days, especially the 3-day lead time. The forecast models are very accurate, especially with track at this point. Intensity still remains kind of that missing puzzle piece of getting it, exactly nail in the head. But we continue. The more work we go do, like I said, the more that the computer models have to learn from, that metric is only going to get better and better.
Very, very cool. Thank you, Nick. That's fantastic. Mm-hmm. All right, we're going to head to YouTube for our first question before we head to our Rainbow Schools Live. Miss A's class, they want to know, have any of your planes incurred major damage from a hurricane? What's the deal with the uptake and maintenance?
So like I said, these airplanes are almost 50 years old, and so we take very good care of them. We have a phenomenal maintenance team who are out there working in the hangar right now, making sure the airplanes are ready to go for whatever the next storm ends up being. I will say that the most harrowing flight that one of our planes has been through was Kermit in 1989, so a long time ago, a couple years before I was born. And they were, back in those days, they used to fly these airplanes through hurricanes at very low altitudes. We don't go any lower than 5,000 feet these days, but they were flying through Hurricane Hugo at 1,500 feet above the surface. And they hit severe turbulence. It was a Category 5 hurricane. They had an engine catch on fire. They had things go flying around the cabin. They had a 90-pound toolbox go up and hit a steel bar, and there's still a dent in that bar to this day.
Wow, that's sketchy. So that experience is why you fly a little higher these days, is to avoid
exactly. Yes, okay. we live and we learn.
Yes. Great question, Mr. A's class. We're gonna head to Miss Dewey's class. Come on in, guys, and come on.
Hello. Hi.
Hey.
Hello.
Hi. Okay, my question is, which categories do you experience most? Like, for example, do you mostly experience like Category 5s or 4s?
Yeah.
Great question. I would say, honestly, the categories we've probably experienced the most are Category 1s, just because a lot of storms don't get up to those higher categories, just because they don't have the right conditions to allow them to strengthen that much. But even Category 1 hurricanes can be very damaging and very dangerous. And so even if it's small as a tropical depression, we'll go fly that storm, we'll collect the data on it, we'll help the forecasters predict where it's going to go. Like I said earlier, I've only been in 3 Category 5 hurricanes, but at this point, I think Milton was my 33rd hurricane, or 32nd. I can't remember.
I want to work on something for a second for our class perspective. So a Category 1 hurricane, how fast roughly are the winds? Because I want to put this in the context for our kids that might have experienced big storms, but nothing like a hurricane before. Is there a figure?
Yeah, so Category 1 winds start at 74 miles per hour. And I think it's 74 miles per hour to about 95 miles per hour is a Category 1 hurricane.
Yep.
And I don't have the Saffir-Simpson scale right in front of me, so I can't remember the exact numbers.
Okay.
But I do know that it starts at 74 for a Category 1 hurricane, and a Category 5 hurricane is 157 miles per hour. So
for our classes, we've got a lot of groups across Canada nowadays. I've stood in 70-mile-an-hour winds once, and it was the most incredible experience ever. You're bent over sideways. The wind is blowing you stationary. Water on a lake is blowing up 10 feet high off the pier. It's insane. You want to run inside as quick as possible. So when I think for us, when we hear storms online, we're like, oh, it's going to be a Category 1 hurricane. Well, that's nothing compared to a 4 or 5. These are very, very serious storms. So it makes them a hurricane. Even a tropical storm or depression is something that you're wanting to get inside, be safe, avoid the risk of a 90-pound toolbox hitting you in the head or your steel bar or anything else. So I'm really glad we got that question. Thanks, Nick. Mm-hmm. All right. Are we getting more hurricanes? So this is a question you addressed a little bit through the talk, but do we see more hurricanes? Do we see stronger hurricanes? Can you speak to that so far?
Yeah, so the statistics are that we are seeing more hurricanes, but part of that, at least, is that we have better sensors to let us know when hurricanes have formed. And so the age of satellites has really given us a lot more insight into storms that form well out in the ocean that never end up impacting anyone, except for some shipping lanes and boats have to go around. But certainly, as I said, as ocean temperatures start to rise, you're just adding in more ingredients that would allow storms to form and allow them to get up to the higher intensities. And so the metaphor for watches and warnings is a hurricane watch is we have the ingredients for tacos, and a hurricane warning is we're having tacos right now. And so if you imagine we're getting more ingredients for the tacos, essentially.
You're making it sound so delightful to have our grain. So there you go. I remember when Milton formed recently, like it was really odd seeing meteorologists and weather people like alarmed like that. I've never seen that in my life. And to be like, wow, this was like a little bit of nothing. And now it's this massive hurricane. It's going to hit here in like 2 days was wild to witness. So I'm really, thanks for the question, guys. Now, you spoke a little bit about this in your talk near the end, but we had a question about, have you ever monitored hurricanes in other countries? Do you ever go down to South America or Asia or anywhere else to check them out?
Yeah, so our office is based in Florida, but we will deploy out to different island countries like Barbados, Aruba. We'll go to St. Croix a lot, Bermuda. We'll even fly storms in the Pacific sometimes. And for that, we'll go to Hawaii usually. A couple of years ago, we did go down to Costa Rica to fly some missions out of there. But the data that we're collecting and the watches, the warnings that the National Hurricane Center puts out, those are all shared. So it's whether it's impacting the United States or Canada or one of our neighbors down in Central America or in the Caribbean, all of that data and information is being shared so that people there can also keep themselves safe, prepare their homes, evacuate if necessary. And so we are able to go to a lot of interesting places to fly these storms.
It sounds like the song, like Bermuda, Bahama. It's very tropical and lovely.
It's a lot of nice beaches.
Yeah. Bad weather on the nice beach. Okay.
Yeah.
Question from our classes: what should you do in the case of a hurricane? And we are nearing the end of the broadcast, so get those last few questions in, everybody. But is there anything you recommend if a hurricane was barreling down towards you, you've got 2 days, you can't evacuate? What should you do with your home and property and everything else?
Absolutely. So if you're in the path of a hurricane and you're not able to evacuate for whatever reason, a lot of people aren't able to, stay away from windows. If you have the means to board up windows of your homes to keep objects from flying through, that's always helpful. If you are near the coast and you are in an area that has the potential to really be impacted by storm surge, definitely try to get to higher ground somewhere. Even if you can't evacuate, out of your community to a different state, 100 miles away or whatever else, definitely get to a point where you're going to stay out of the water, because the water is the biggest threat when it comes to hurricanes. That's what causes the most deaths from these storms. And so definitely, hide from the wind, run from the water.
Yeah, we've been seeing a lot of footage in the last few years when hurricanes come through. People are going for like a light little paddle on the road or let's go. And, these are really, really dangerous activities. Water is really unpredictable. We hear this from a lot of storm hunters that we've had on the broadcast before. So it's been a universal piece of advice, and hopefully nothing that any of our classes are ever going to have to experience. But stay away from the water. Take groups like the Hurricane Hunters and the Weather Service's recommendations seriously. Get out if you can. All really good messages. Nick, before we wrap up, and thank you so much for spending some time with us and all your expertise again today, is there any last message you'd like to share about the Hurricane Hunters, about storms, NOAA, anything to leave us with before we say goodbye?
Yeah, people often ask, how do you get this job? How do you go and, have a job that's so exciting? And I studied engineering in college. I have a degree in aerospace engineering, but we have people at our office who are pilots. We have meteorologists. We have aircraft mechanics. And so there's all these different ways that if you're interested in this mission and you want to eventually be part of it, Those are the kind of careers I would recommend pursuing. And also, lastly, is that we fly these missions, we put ourselves in danger to give this warning, to give enough time for folks to prepare to evacuate, and it's all for naught if people don't listen to those watches and warnings. So if you are told to evacuate, if you are told you're in a dangerous area, please pay attention to local forecasters, pay attention to the National Hurricane Center, and make our job worth it.
Yep. There's no better message than that. Thank you so much, Nick, for everything today. Again, keep up the amazing work. And as always, we'll say farewell to all our classes online, live, after the fact, wherever you're tuning in from. Really appreciate you joining, and have a wonderful rest of your day.